The sandwich theorem, or as it's called sometimes the squeeze theorem, deals with finding a limit of a function when it is squeezed between two other functions. This can be described as given two functions, say h of x and g of x, and the point where they sort of touch is going to be point x equal to c, then the function that is squeezed between these two functions will always have to stay between them. So at point x equal to c, the function f of x is going to have a limit equal to h of x and g of x. You might wonder why would we even care about such a scenario, the limit of f of x at point c, and we are then able to choose h of x and g of x such that f of x is always squeezed between them, and then its limit is going to be equal to the limit of h of x and g of x. When I was first learning about this theorem seemed very intimidating to me, because I always wondered, well, what is g of x and h of x, and how would you even find them? However, in a typical problem given on squeeze theorem, h of x and g of x are already given to us, and the problem states that f of x is always squeezed between those two functions. So solving the problem becomes a matter of finding the limit of h of x and g of x at x equal c, and then saying because of squeeze theorem the limit of f of x is going to be equivalent. Now I will write the squeeze theorem a little more formally. So here we are given g of x is less than or equal to f of x, and f of x is less than or equal to h of x. And we know that limit as x goes to c of g of x is equal to limit as x goes to c of h of x, which is equal to L. Then applying limits to our inequality, we'll have limit as x goes to c of g of x is less than limit as x goes to c of f of x is less than or equal to limit as x goes to c of h of x. We know that limit x goes to c of g of x and h of x is equal to L, so we'll have L is less than or equal to limit as x goes to c of f of x less than or equal to L. So naturally the limit of f of x is forced to equal to L. Now I will give an example problem for squeeze theorem. Okay, so in this problem, f of x is equal to sine of x over x, g of x is equal to minus x squared plus 1, h of x is equal to x squared plus 1, and we are told that g of x is less than or equal to f of x, and h of x is greater or equal to f of x. And we are asked to find limit at point x equal to 0. Clearly, function f of x is undefined at x equal to 0 because we have 0 in the denominator. So now we will find limit of g of x and h of x as x goes to 0. So limit as x goes to 0 of minus x squared plus 1. Since it's just a polynomial, we can solve this limit via substitution, which will give us 1. And as limit as x goes to 0 of x squared plus 1 is going to be equal to 1 in a similar way. So then by the squeeze theorem, we will have that 1 is greater or equal to limit of sine x over x is less than or equal to 1. So we have that limit as x goes to 0 of sine x over x is equal to 1. And that's the solution. And typically, this is the procedure behind most of the squeeze theorem problems.